Okay, numbers 21 through 30 for review C. Number 21, you're asked for the rate at which W is changing with respect to time when X is 4 and Y is 20. So start by finding dW dt, which would be the first times the derivative of the second, plus the second times the derivative of the first. And remember, we're doing this with respect to time, so you have to put dy dt and dx dt. Then what you want to do is plug in the known values. So 4 for X, 20 for Y. And it says that X is decreasing at a rate of 1 unit per minute. So that's going to be dx dt for -1. And then Y is increasing by 2. So what we'll have here is X is 4, dy dt is 2, Y is 20, X is 4, dx dt is decreasing, so -1. So we have 16 times 2, so 32. 20 times 2 is 40, times 4 is 160, times -1 is -160. And we get -128 units per minute. Okay, number 22. We're looking for decreasing and concave down. So we're going to have to find f prime and f double prime. So for f prime, we have 6x squared minus 6x minus 12. When we set that equal to 0, we'll want to take out the GCF. So that'll be 6 times x squared minus x minus 2. Factor further, and you've got 6 times x minus 2, x plus 1. Okay, so in this case, x is 2 and -1. Okay, so if you set up your table here, you plug back into f prime because we're talking about increasing and decreasing. You put -1 and 2. You're going to get a positive for less than -1, negative for in between, and positive for greater than 2. So what we're focusing on here is where it's decreasing, so -1 to 2. Now we need to find where it's concave down. So f double prime is going to be, let's see, 12x minus 6. Okay, so x is going to be 1/2. So we set up another table. We put 1/2 in the middle. When I choose something less than 1/2, like maybe 0, I would get a negative. If I plug in something like 1, I'd get a positive. So it's concave down here. So we're looking at where these two intervals overlap. So from -1 to 1/2. Okay, on the next one, we have a piecewise function. We want to know the derivative at 1. So we're going to differentiate each piece. So f prime is going to be 2 for x is less than 1, and -4x for x is greater than or equal to 1. Now look at this. If you plug in 1, I'd have 2 here and -4 here. Well, 2 is not equal to -4, therefore the derivative does not exist at 1. Okay, so I would say not differentiable, or no solution, or it does not exist. I'm just going to put not differentiable in this case. Okay, number 24, we've got the function f. We want to know the horizontal asymptote. So horizontal asymptote is the same thing as limits as x approaches infinity or end behavior, all the same question. We need to be able to see the highest power of x on top and the highest power of x on the bottom. So if I go ahead and distribute this, I would have 5x minus 2x squared plus 30 minus 12x divided by 4x squared plus 4x plus 1. So I'm focusing on the highest power of x on top and the highest power of x on bottom. Because they're the same, we do coefficient over coefficient. So -2/4, which is the same thing as -1/2. Remember, low over high, y equals 0, high over low, none. Same over same, coefficient over coefficient. Okay, on 25, we're given y and u, and we want to know dy du. Okay, so what I would do here is I would take y and I would find dy dx. So that'd be 2x minus 1. I would find du dx. That's going to be 3. And if you put dy dx over du dx, what you'll see is that the dx's cancel, right? If I were to multiply by the reciprocal here, the dx's would cancel out. So we have dy du. So dy dx over du dx is 2x minus 1 over 3. Okay. On number 26, Let's see, we're asked to find the derivative of an integral. So what we're going to do is we're going to take x squared and we're going to plug it in, and then we're going to multiply by the derivative of x squared. So we'll have 2 divided by 2 plus x squared squared times 2x. So it's going to be 2 divided by 2 plus x to the 4th times 2x. So our final answer will be 4x divided by 2 plus x to the 4th. Okay. All right, 27. We've got particle motion again. We've got the position function given here. We want to know when the particle is at rest. When you see the words at rest, you're thinking velocity is equal to 0. Okay, so we need to first differentiate, find v of t. The derivative of cosine is negative sine. And this is the chain rule, so the derivative of the outside is negative sine, the derivative of the inside is 2 pi. And then the derivative of 2 pi t is 2 pi, because that's a constant. Now we need to set that equal to 0. Okay, so I would have 2 pi equals 2 pi sine 2 pi t, because I'm going to add that sine to the other side. If you divide by 2 pi, it's going to cancel out. So 2 pi divided by 2 pi is 1 equals sine 2 pi t. And what I would think of here is, at what value of theta is the y coordinate 1? Well, y is 1 at pi over 2. So I need this whole value inside here to equal pi over 2. Okay, so you can kind of think of it like this. Y equals sine u, and u is 2 pi t. Okay, so u would be pi over 2. So now take u, 2 pi t, and set it equal to pi over 2. Okay, so we need to divide by 2 pi. And t is going to equal, go ahead and multiply by the reciprocal here. The pi's cancel and we have 1 over 4. Okay. All right, on number 28, we're looking for the slope field that matches the differential equations. What I notice is that we have the slope kind of flattening out here along the line y equals x. You see how it's flat along the line y equals x? That means dy dx is equal to 0. So if you think about it, the slope is 0 in this case when x would equal y. Okay, so if x equals y, the slope would be 0. So that's going to be this equation, b. Okay, again, particle motion on number 29. It says write an expression that gives the average velocity. Velocity is rate of change. So average rate of change, or the slope of the secant line, is always going to be y2 minus y1 over x2 minus x1. Okay, average value is when you do 1 over b minus a times the integral from a to b of f of x dx. That's different. Average value is an integral. Average velocity, or average rate of change, is the slope of the secant line, which is just the slope formula that you learned way back in algebra. So we would do the position at 6 minus the position at 1 over 6 minus 1. So the change in position over the change in time. And that's your answer. And I'd probably actually go ahead and make this a 5, but that would be all I'd do. Okay, last one. If sine 2 over x cubed plus 2 is an antiderivative for f of x, then the integral from 1 to 2 of f of x dx is. Okay, this one's going to require you to use your calculator. Let's see, the integral from 1 to 2 of f of x dx would be equal to the antiderivative at b. Well, if sine 2 over x cubed plus 2 is the antiderivative, then you would just plug in 2 for x. So sine 2 over 2 cubed plus 2. The antiderivative at b minus the antiderivative at a, and a is 1. So we'd put 2 over 1 cubed plus 2. And I would just put this straight into the calculator. Okay, so make sure the mode is in radians. Okay. And we're going to do sine 2 divided by 2 cubed is 8 plus 2 is 10, so 2/10, minus sine 2 divided by 1 cubed plus 2 is 2 divided by 3. And we get negative 0.4197. And that's your answer.